For this video, let's take a look at the inside of the SGC SG-2000. This is the high stability crystal oven. It's got a heater and a thermostat, and you can have it either stay on all the time or not, depending on the switch. This is the digital logic, the computer, the EEPROM, memory channels, all that are stored in here, plus the computer's program on EEPROM. Right here, this is the broadcast band rejection board. Normally, the receiver is wired through this board. In my case, I've jumped around it and I've got this injection set up because of the problem I'm having with the low-pass filters. These are the VCOs. A DC voltage varies the oscillator frequencies from them, and they go into here to do the multiplication, basically 3 stages of IF. Right here is a 30 megahertz filter, so above 30 megahertz doesn't get into the receiver. And these are the Mini Circuits Company mixers. There's actually 3 of them, 1, 2, and the third one is under here somewhere. This is probably very sensitive circuitry. The alignment for the whole radio is given in the service manual, and it's very, very well explained. I really appreciate that they showed even what they did at the factory, how they would test it out and hook up their test jigs. I think that's really cool. You'll notice this radio has staking, or gluing. A lot of the tall components are glued like this electrolytic capacitor here. And that's just to make it last longer in an environment where there's vibration. This cable goes over to the amplifier board. These are the various alignment points for the receiver. The telex and AGC jumper is located down here. Let's zoom in. So right here you can move this jumper depending on if you want ALE, automatic link establishment mode, which is where they run the AGC differently. It's not disabled, but it's differently run. And then down here is the so-called telex mode. In the telex mode, the button switches in a narrowband audio filter. In the ALE mode, you just get the different AGC, and that's what I've set this for. I may change that later, haven't decided yet. And right up here, this is where the transmit drive is set. This cable goes over to the transmitter board, so let's check that out. Here is the power amplifier board. You can immediately see the 4 MRF 455 transistors. Each one is rated to produce 60 watts. These are the combining transformers. This is one of the jumpers you can pull out if you want to measure the current of this section of the amplifier directly when you're setting up the biasing. The bias is adjustable per pair of transistors, so one pair can go out and get replaced, and then the bias is adjusted just for that pair. That's kind of nice. Supposedly this radio was built so that if one transistor goes out, the other pair will continue to operate, and you know, at lower power. That would be a nice feature if you're at sea and you don't have spare transistors with you. Oddly, even though the electrolytics are staked with that snot, these are not. You'd think these coils would be staked, but they're just here flapping around the breeze. So that's another thing we'll correct as we work on this radio. These are individual fuses for either side. Each one's 15 amps. I'm going to probably put 20 or 25 amp fuses in here just so there's less resistance getting into the circuit. This is the power wire, and I think we can all agree this is pathetic for something that can consume 30 amps. I don't think this, what is this, 18 gauge wire? I don't think this is appropriate. There's 2 of them, I like that, but it's just not enough. So we're going to beef that up, and we'll beef up this one too. This relay here is a protection relay for the high voltage that could come through, like if you hooked up to 24 volts or something. But the contacts are, of course, holding back how much power the amplifier can make because there's contact resistance. So I might change that circuit around. I might put a heftier relay in there. Certainly a newer one would be a good idea. Right here is the temperature sensor. This is an isolated section of circuit board, and the temp sensor feeds the processor and another circuit, which can then turn on the fan with a circuit that's not in the radio. That was sold separately, I guess, for higher duty cycle people. We're going to definitely put that in this radio though. Up here we have the low pass filters. There's one for each band. They're about 4 megahertz. I think the first one clicks off at 2 megahertz, and at 4, then at 8, and so on per octave thereof. These are only low pass filters, which is fine for a transmitter where the harmonics produced are higher and you need to suppress them. But it is not appropriate for a receiver where lower frequency signals can come in and ruin your dynamic range. So I may experiment with adding a high frequency shunt onto one side of these filters. I might not too. I don't know. We'll see. Something's got to be done though, because this radio can perform really well in a quiet environment. These are the relay drivers right here. This chip directly pulls down the grounded side of the relay, and I think one of these transistors here pulls the other side up. Over here is the SWR and forward power sensing circuits. Mine aren't working. They read really low values. The ADC for them, I think, is over here somewhere. I got to confirm that. So yeah, all these relays have to come out. Each one's going to get pulled out and a new one will get put in. That means I have to take out all these screws and everything. It'll be a fun video. You guys can enjoy that with me. Okay, that's all for now. Join me next time when we look inside this head unit and when we put these relays into the low-pass filter board for the repair. Thanks very much, and 7-3.